A car's position is given by the function s of t equals 5t squared plus 2t, where the s is measured in meters and t is measured in seconds. What does the derivative s prime of t represent in this concept? Well, this is a particle or a position type problem, okay? Rectilinear motion, it's called. And whenever you're given the position function, its derivative is going to be the velocity at a given time. So this is basically just a introduction to Unit 4, where we are simply asking you, hey, what does the derivative of a position function give you? Velocity. If you're curious, the second derivative would give you acceleration, but I didn't ask you that, now did I? So thanks for watching. Like and subscribe. The temperature T in degrees Celsius of a cup of coffee over time T in minutes is modeled by the function T of T, oh boy, that's not confusing at all, equals 100, blah, 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 blah. What does T prime of 5 represent? All right, so you have temperature with respect to time. When you take the derivative, you are given a rate. Okay, so your T and your T is going to be temperature, the rate of the temperature over that many minutes time 5 minutes. Okay, so it's the rate of change of the temperature of the coffee after 5 minutes. So yeah, maybe I could have done a better job describing that, but when you take the derivative of something, you find the rate. Okay. And since we have, usually rates are like miles per hour, but this is going to be temperature over minutes, right? And when you use 5, you are plugging in 5 into little t, so you're talking about 5 minutes, so the rate of change of the temperature of the coffee after 5 minutes. So there you go. Explained it poorly the first time, explained it slightly better the second time. You're welcome. Thanks for watching. The home price index as a percentage change from the year 2003 in year t is represented by y equals p of t. So we're given y equals p of t, this weird function where the home price index, whatever that means, goes up and then peaks out and then goes down and levels out and blah, blah, blah. All right. What year does p prime of t equal 0? Well, p prime is the derivative. The derivative means slope. So when it's asking you when is the slope equal to 0, it's asking you when is the slope completely flat and horizontal. Okay, so I'm looking at this and I'm pretending slope is kind of like if I were to be on this thing riding a skateboard, where would my skateboard be completely flat? Well, always at the top of a hill or at the bottom of a valley is where it's going to be completely flat. Okay, I'm going up, going up, going up, going up, going up, and the minute that I hit the tippy top here, I am flat. That is the year 2006. So the year that my derivative is 0 is asking when is the year that my instantaneous slope, my instantaneous rate of change is horizontal, and that happens at the year 2006. Similar question, is p prime, so again, the slope, of 2008 positive, negative, or 0? So I'm going to this, I'm pretending I'm on my skateboard, and at 2008, right, I am going down this hill. So at that moment at 2008, I have a negative slope because my slope is going down and to the right. Now C is asking us to find the average rate of change from 2006 to 2008. So I'm going to look at those 2 points right there, 2006 and 2008. 2006 is right there. That's the point 2006, 40. 2008 is right there. That's the point 2008, 25. Now what I'm going to do is I'm going to use the average rate of change formula, which is f of b minus f of a over b minus a. Okay, let me change my pen. There we go. We'll call the earlier year a because that usually makes sense. So you would be f of a. We'll call the later year b, so you'll be f of b, like so. And it's just a matter of plugging things in. F of b is 25, minus f of a is 40. Regular b is 2008. Regular a is 2006. 25 minus 40 is negative 15. 2008 minus 2006 is 2, and we could basically just call that negative 15 over 2. Unless you want to call it negative 7.5, that's perfectly fine. Now, why does this make sense? Well, going back over here, if I were to find the average rate of change, that's them asking you to find the slope between 2 points. So my slope would look something like this if I knew how to draw a straight line. And if I were normally, like back in Algebra 1, being asked to find the slope of a line, you would just take those 2 points and say, oh, okay, well, every time I go down 5. So down 5, 10, 15. And every time I go over 1. So over 2. Down 15 over 2, negative 15 over 2. Easy peasy. So yeah, that's how you do that problem. Lots of derivative stuff, but also lots of fun. The number of iPods sold by Apple each year from 2004 through 2007 can be approximated by this formula right here. It's a quadratic in millions of iPods where t equals 0 represents 2004. Lots going on here. So I know that this is a parabola, and when graphed it's going to look like this. What I don't know is where things change, and that's going to help me understand A and B. All right. A is asking where it's increasing or decreasing. Well, I don't know where it's increasing. I don't know where the vertex is. I could find it, but I'm going to use calculus to do it instead. If I want to know if it's increasing or decreasing, I can just find the slope and see if the slope is negative or positive. Now, how do I use calculus to find the slope? Take the derivative. F prime of t is going to give us the slope, okay, at any given t. So when I take the derivative, this is just power rule, the derivative of negative t squared is negative 2t. The derivative of 20t is plus 20, and then plus 3 does nothing for me. Now I care about 2006. Does that mean I plug in 2006? No, 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 no. 0 is 2004. So 2006 implies that t is going to equal 0 because t equals 2 because it's 2 years later. So I'm going to find f prime of 2. F prime of 2 is going to be negative 2 times positive 2 plus 20. Negative 2 times 2 is negative 4, and negative 4 plus 20 is positive 16. The key word there being positive. And what this means is since I have a positive slope, remember derivative gives us slope, since I have a positive slope, that means it is increasing at that number right there. So the answer to problem A is increasing. Okay? Fun stuff. Now B is saying, what is the average rate of change from 2004 to 2007? So I'm going to use the average rate of change formula, which is f of B minus f of A over B minus A. The frustrating thing here is I don't have any information except for the fact that I can find out what my years are. All right? 2004 is the year 0. Which means 2007 is going to be 3 years later, the year 3. Now, do I have my y values? Do I have my f of a and f of b? No, I don't. So you would be my a, you would be my b. In order to find f of a, what I'm going to do is find f of 0 by plugging it into the original function. So negative 0 in parentheses squared plus 20 times 0 plus 3 is going to be 0, 0, and 3. You get 3. So f of a is going to be 3. F of b is going to be me plugging in 3, so f of 3, and that is going to equal negative 3 squared, again I'm plugging it into the original function, plus 20 times 3 plus 3, which is going to be 9 plus, I'm sorry, that was a close one, negative 9, plus 60, so 51, plus 3, 54. And that's f of b. So let's plug it all in. Let's plug and chug. All right, f of b minus f of a is going to be 54 minus 3. b minus a is going to be 3 minus 0. Okay, 51 over 3, I'm pretty sure is 17. So the average rate of change is going to be 17 million. Now, where did I get that million from? I don't think Apple only sold 17 iPods per year. They probably sold a few more than that. I don't know. I don't know business, but it says up here that it's in million. So the average rate of change is going to be 17. Between 2004 and 2007, they sold 17 million iPods or iPads or whatevers per year. And yeah, that's how you do it. Fun stuff. The graph of the differentiable function y equals f of x is shown below. Which of the following is true? So we've got this parabola-looking guy. It's decreasing there, it's increasing there. We have a bottom there. So knowing calculus, we're probably going to talk about the fact that the derivative, and we'll say this, let's use words. The derivative, right, is going to be negative. Since it's decreasing, that means the derivative, which is slope, the derivative is going to be negative on the interval negative infinity to 1, but not including 1. It's going to be 0 at 1, and it's going to be positive from 1 on to positive infinity. All right, now, whether that's exactly what we're looking at, I don't know. I'm supposed to find out which of the following is true. So, the derivative at 0 looks like to be negative 1-ish, right? So like that, the derivative at 0 is like negative 1-ish, and that's going to be greater than when you plug in 0. Okay, well, let's look at each part. Okay, the derivative at 0 is negative. When you plug in 0, you get 0. Is negative bigger than 0? No, A is not true. All right, so let's get rid of that. B is saying the derivative at 1 is 0, and when you plug in 1, you get negative 1. Is 0 less than negative 1? No. So you're not true. F prime of 2 is going to be some positive slope, right? And f of 2 is 0. Is a positive number less than 0? No. So far we're striking out big time. Striking out big time. F prime of 1 is going to be the derivative at 1, which is 0. 0 is equal to f of 0, which is true. F of 0 is 0, and the derivative at 1 is also 0. D is true. Now, I'm assuming we're maybe just finding 1. Maybe this is one of those select all that apply. I could be wrong. Let's just keep going. F prime of 2 is going to be some positive number we don't know. F of 2 is going to be 0. Is a positive number bigger than 0? No. So this is one of those only one answer things, and the only one answer that seemed to work is D, baby.